of the SDDC. And some of the advantages with that are you have location independence. So you could have your private data center, you could have inter data centers, you could have a hybrid private public data center, and you're physically you're independent from the physical infrastructure. So you can use all your existing infrastructure that's there, all the physical infrastructure, but you also have the flexibility so you can get that best price performance, for adding capacity and for new deployments and things like that. And, since you're physical infrastructure independent, of course, what you're actually using is a virtual infrastructure. And this is your software-defined data center infrastructure, and it's totally decoupled from the physical network. And what it gives you is it gives you the operational model of a VM for your entire data center environment. It gives you complete visibility, security, and scalability for the entire data center. And, of course, your applications, any application, on-demand provisioning, isolation, mobility, speed and agility for any one of your applications. And, as far as consuming the applications from the consumption side, they can be consumed anywhere, anytime, on any device, whether it's offline or whether it's a mobile device or at home or at work or, in the office, wherever. So, that is the SDDC, in a nutshell. So it allows you a lot of advantages over the old legacy defined, hardware-defined data center. So where does it all start? It all starts with your physical network infrastructure. So, you're already familiar with the physical, network infrastructure, and, you have your servers and storage as well as the, your networking equipment and everything. And, the good news when you're working with the SDDC and when you're working with NSX, the physical network, it could be anything. It's not tied to any one, specific type of vendor hardware. It could be Cisco, could be HP, could be Dell, could be, IBM, could be any type of, underlying hardware. And from the networking side, it could be any networking hardware that forwards IP packets. So it's not limited to any one vendor, and it could even be a mixture of vendors. So, the real important thing to understand about this, though, is that, NSX works on top of the infrastructure that you're already familiar with. And you really don't have to virtualize the entire network if there's not a need to do that. You can virtualize any part of it, or you could virtualize the entire, data center if that's what you need to do. And NSX just uses the existing network that's already there, as an IP backplane. And we'll look at that a little more as we go forward. So then, on top of your network infrastructure, of course, you have your, your compute capacity, and that's where, all your the servers, your hardware servers and your hosts, if you're using vSphere already, is already running. And then, of course, on top of the compute capacity, that's where you have your data center virtualization layer. This is where your vSphere hypervisor is running, and this is where the actual servers are being virtualized and everything. And this is where the hypervisors and all the virtual switches exist. So then, what NSX does, NSX takes advantage of that infrastructure that's already there, and it creates what you could really call a network hypervisor. So just like vSphere does server virtualization and it's got that host hypervisor or the server hypervisor, the NSX provides you a network hypervisor which overlays the entire network infrastructure. And how it does this is by distributing network services into the hypervisor. And they can be provisioned, along with the application workloads, and they can take advantage of the application context because they're operating right at the application's interface to the data center construct. And, a big misunderstanding that some folks that are new to this might have is that the network itself actually needs to change. That physical infrastructure needs to change, but it really doesn't, okay? And, as an example, 85% of VMware's customers are already virtualizing, existing maybe Cisco 6K or 7K infrastructures. And they even have, a lot of customers that right now are building greenfield data centers, and they're virtualizing new Cisco 9K leaf spine fabrics. So, again, it's not limited to Cisco, but that's just the example that they're using. And, again, the physical underlying network, it could be anything. It's just not limited to one specific vendor. It could be any networking hardware that forwards those IP packets. And what it does is it effectively gives you that operational model of a VM for the entire network. And, again, as I mentioned earlier, like the server hypervisor creates your software or your server virtual machines. The NSX network hypervisor, it enables the creation of software virtual networks. And it's really as simple as that. These virtual networks, they can be created, they can be saved, they can be deleted, they can be restored, just like virtual machines, but for the network. So it really, streamlines everything and makes it a lot more efficient. So what you're looking at here is, this is an example of a software-defined data center deployed. And what you got is you got, 3 L2, switches, and they're connected by an L3 router, which is giving you, 3 L3 subnets. And you have your web tier, your app tier, and your database tier. And, you've got like 2 workloads shown here on the web tier. You've got a workload on the app tier, and you have a, workload on the database tier. And you can see your physical network is all still there. That's the underlying physical infrastructure. But with the SDDC, you could have all your policies in place, all your security policies and rules. So as an example, you can restrict the web tier to talk to the app tier and the app tier to talk to the DB tier, but you could prevent that web tier from talking directly to the DB tier, which you would obviously want to do for pretty obvious reasons. So that's just an illustration of the SDDC. And in the example that we're showing here, we're using NAT, okay, to connect to the outside world. But depending on how you set it up, whatever your needs are, you could use static routes, or you can use dynamic routing, such as maybe BGP or OSPF. But the example here is using NAT. So let's take a quick look at a traditional virtual switch. All right. So if you're working with vSphere already, you should be pretty familiar with how the virtual switch works. So when ever VMs want to talk to each other, on the same host, the packet just goes out, it goes to the vSwitch, and it goes back to the VM next to it. So the packet never does get out on the physical network. And one important thing to note is VMware accomplished a milestone a few years back where in 2012 they actually passed a threshold where they have more data center workloads connected to virtual switch ports than to actual physical switch ports. So there's a wide adoption of what VMware is doing with vSphere and everything. And again, this is starting to really show in the NSX arena as well, as the adoption is really intensifying and speeding up with people adopting NSX. But now we're looking at this traditional virtual switch, and we looked at the 2 VMs, on the same host. But, what happens if we take that and we have 2 VMs that are on different subnets, and they could still be on the same host? Well, what happens then, you could see here in the illustration, is that traffic actually has to leave the host, traverse the physical network, go out to a physical router, then come back through the physical router, back to the physical network, back into the host, up to the standard vSwitch, and then back up to the other VM. And, this uses a lot of, bandwidth. It uses a lot of resources and, a lot of cycles and everything. So, it's really, it could be more efficient than it is, okay? And what this is typically referred to as, this type of traffic, it's called hair pinning. Where it has to go back out and back in. And, in the world where we live in now, where, there's just more and more, magnitude, more address magnitude happening, where the addresses are just, the IP addresses are just increasing, networks are just growing and more networks are being deployed. And there's a lot more east-west traffic on those networks. So, web servers are talking to your app servers, talking to your database servers, inside the data center. You have a lot more of that traffic than actual north-south traffic, which is going in and out of the data center. So a lot of this hair pinning, it puts a lot of that pressure, on the oversubscribed core of most data centers. That three-tier physical architecture. The web, the app, the database tiers, and once people to be able to move to, more of a, two-tier, like a leaf spine architecture, if you will. But, we'll talk more about that a little bit later on. So, what actually is a virtual network? So, looking at the illustration here, okay, a virtual network, okay, all it is, it's a software container, and it delivers your network services that are that connected workloads, expect from a network, And, with the, virtual network, you have your, logical switching, that's your layer 2 connectivity, and it could be between two VMs on the same hypervisor and host, never leaving the hypervisor, or, it could be between two VMs on two different sides of the data center across multiple L3 subnets and availability zones, and we'll look at how, by using NSX, it's going to eliminate that hairpinning issue that I mentioned earlier. And you also have your logical routing, and this is your layer 3 connectivity. And again, it could be between two VMs on the same hypervisor and host, but different IP subnets, and different logical switches without ever leaving that hypervisor to use a physical router. Or it could be between two VMs on two different sides of the data center, again, without ever leaving that virtual network construct. And we'll look at that more, as we go forward. But what you also get in addition to those two is you get your logical load balancers and you get your logical firewalls. And it's all software. It's all isolated from any virtual network, and from the underlying physical network. So you could see here, where there's, the two VMs are communicating. And then, of course, here you have the VMs communicating across, the network. And, one advantage to the, virtual network is you have that non-disruptive deployment. And you can see when you deploy this, the underlying network, it's all still there. There's no disruption, and there's nothing is disturbed on the actual physical network itself. So where this all gets provisioned from is through your cloud management platform, okay, or your CMP. So when the VMs get provisioned, the cloud management platform, what it does is it calls out to the cluster controller, and there's an NSX API that gets exposed by that cluster controller. And what the actual controller does is it creates all of the distributed network services that are associated to those VMs. Your L2 and L3 networking, your firewall, your load balancer, any ACLs that might be associated, your quality of service. And it pushes all those services into the vSwitches, of the hypervisors where the VMs will be residing. And the cool thing is, just like when you're virtualizing regular servers for individual VMs, if you move a VM, of course, when you're server virtualization, everything moves with it. Well, just like here, okay, so if you move a VM, everything is going to move with that VM. Okay, all those networking services, the firewall, the load balancing, everything, it's all going to stay right with that VM. Nothing has to be reassigned. So what you're looking at here is the traffic that's going from, one VM on one host going to another VM on the other host, all right? So these VMs are communicating, and again, keep in mind, all right, it's all really being done on the virtual network, okay? The traffic is, of course, it has to pass over the hardware, but remember, it's merely using the physical network as an IP backplane. You don't have any VLANs, there's no ACLs, there's no firewall rules. So everything is being handled by, what VMware calls the VTEPs, okay, which are, specialized interfaces in the actual hypervisors on either end of the communication. So these workloads, they're only going to see that physical network. They don't even know they're only going to see the virtual network. They don't even know the physical network exists. And the physical network is just going to, those packets are just going to pass through it, and it doesn't have to have any type of additional configuration on that physical network. And, of course, the VMware, can support that physical infrastructure QoS, as I mentioned earlier, and, it does that by simply marking the packets, in an encapsulated header. So, whatever you need to do with those packets can be taken care of, through the virtual network. And of course, you have your native isolation. That's also part of that. So what you're looking at here is, an illustration of those networks being, natively isolated from each other. You have your blue subnet, you have your green subnet, and you notice they're using the same, subnetwork numbers and even the same IP addresses. And, that's what the advantage to this does. It allows you to use those overlapping IP addresses, like maybe if you have a multi-tenant environment. Multi-tenant, could be different departments within a company, it could be different sites, it could be, whatever. But you can keep all of those, different subnets separated from each other, using that network virtualization. And, again, it's all isolated, not only from each other, but from the underlying physical hardware. So, again, there's no ACLs, there's no firewall rules or anything, that you have to associate any of this with, so you can really, overlap those IP addresses. You don't have to worry about that, from the physical side. Where this gives you a lot of advantage too is, if you need to have like, maybe dev, or test, environments set up, and maybe production environments, and all three have to be run on that same physical infrastructure, you could have three virtualized networks, one for your dev network, one for your test network, and one for your production network, and they could all use the same IP addresses. It doesn't matter. So, and in addition to that, you can also connect to and communicate with the physical network if it's necessary. And you can do that through an x86 gateway server, and that's just a server running the NSX gateway software. You can connect to individual physical servers, individual workloads, or if you want, you could connect to an entire VLAN, or a complete VLAN of physical or virtual workloads. So you could see there's a lot of flexibility there, as far as you could just have everything on the virtual network itself, and totally isolate, not communicating with the physical network. But if it needs to communicate with the physical network, you do have the option to do that. Okay, and that's what is commonly referred to, as I mentioned earlier. Your east-west traffic is all the traffic that stays on that virtual network. And the north-south traffic is the traffic that goes in and out of that virtual network, communicating with the physical network. And again, you can do that, through using the NSX gateway software running on an NSX gateway server. Or you could actually use partner TOR, top of rack switches, that support that OVS, DB VTEP, and that's a specialized VTEP. And you mentioned, excuse me, and if you remember, I mentioned the VTEPs earlier about their specialized, connection points inside each one of the hypervisors at either end of the connection on the virtual network. So there's these are hardware VTEPs where the communication points are actually residing in that partner hardware, if they support that. So again, you can see there's a lot of flexibility as far as how you do that. So, and what we're looking at here is an example of the non-disruptive deployment that I mentioned. And what you could see here on the left, when you're looking at east-west layer. Okay, so this is working in the same host here, where you could see for one VM to communicate to the other one, like we showed earlier, where it's got to actually go out, through your fabric, out to your course, router all the way back in, to that other VM on the same host. But with NSX, it eliminates that because the traffic never leaves the host. All right, and even when you're looking at communicating between VMs on two different hosts, it doesn't have to go all the way out to the, to the core, if you will. It just uses that, the fabric there. So it eliminates all of that hairpinning issues that we mentioned earlier. So, and this also applies, to your firewalling. All right. So, same scenario when you're, east-west firewalling on the same host. It's got to go all the way out to the firewall, come all the way back in, and with the what we'll mention a little bit more earlier, the micro-segmentation piece to NSX, where you can have a DMZ anywhere. You actually have your firewalls, here at the VM level, where it's just going from VM to VM. It never has to leave the host, and then again on separate hosts, it's not going all the way out to the perimeter firewall. It's only using that aggregated fabric inside. So again, it's a lot more efficient. So, looking at SDDC, it is really, the best approach. The software-defined data center, you've got, any application, with your OS, you've got, your hypervisor, and, any x86 hardware, any storage, any IP network. And you have all your network services that are actually running in the hypervisor. And, your SDDC approach, it gives you that high context, and it gives you the high isolation, and it gives you ubiquitous enforcement. And your context, for those of you that work with firewalls, there's different types of firewalls. You have your perimeter firewalls where you're going to get that, high isolation. It's going to be very isolated, but, you're not going to have a lot of context. And conversely, you might be putting maybe some firewalls as some of your endpoints. Well, in that respect, you're going to have the high context because it's right there at the endpoint, so there's going to be a lot of, contextual information, but there's going to be very little isolation. So what NSX does, it combines the best of both of those, where it gives you that high isolation you get with a perimeter firewall. And by no means is VMware telling anyone to eliminate their perimeter firewalls. Of course, they absolutely do serve a purpose, all right? But this is just, telling you you're going to get that same, level of high isolation with NSX, but at the VM level, and you're also going to get that, the high context. So you're going to get the, best of both. And, of course, you get the ubiquitous enforcement to go with that. So it's just pretty much enforcement everywhere. And, of course, no platform could really be complete, any true platform, unless it really has successful participation of third-party partners and it has that third-party ecosystem. And, NSX, of course, has that. It's a very rich, ecosystem of partners, and it spans across, physical to virtual, and it also, operations and visibility, app delivery services, security services, so all these different categories are covered with, the extensive partner network that VMware has, with this NSX partner ecosystem. And of course, because it's all, extensible and distributed, it supports the real novel concept of dynamic service chain, and it provides multiple platform integration points, and it helps, automate the, your deployment, orchestration, and your scale out of all these partner services. So everything is all, works together to give you that, best possible performance on your networks. So these are some NSX customer use cases, and as you can see, there's like 3 areas. There's actual 9 use cases, but they encompass 3 different areas. So what you've got is you've got your, under security, of course, inherently secure infrastructure, and we talked about that, the high, high context and the high isolation. You have the micro-segmentation, and that's what I was mentioning earlier, where you can segment different areas into their own separate networks and keep them separate. Whereas when I mentioned the example earlier, you could take that web tier and you could take the application tier and you could take the database tier, and you use micro-segmentation to separate them, so the only communication actually goes on within that particular tier. And then with whatever type of rules or policies you set up, you would restrict or control any communication going between the tiers. And then, of course, your DMZ anywhere, you could have, the firewalls, it's at the VM level. And, if you move the VM, the firewall follows it, the load balancer, and, the L2 switching, the L3 routing, that all follows the VM wherever it goes. And, it allows you to have that DMZ anywhere. And, of course, because of all of that, you have your secure end user as well. And under automation, it's just the IT automating IT, self-service provisioning, automation, things like that, where anything where, sometimes it could take maybe, 3 weeks to a month or, longer to deploy applications or resources or anything else, it can be done in a matter of minutes or even seconds, with automation. And, of course, there's the developer cloud where you could have a secure, developer, area. And, it can, again, be self-service where if they need resources, instead of having to go out and, file a requisition and have that be approved and move through whatever resources it has to go through to get approved, then go back to IT to go ahead and be, deployed. It's, self-service, and it could be deployed in a matter of, minutes or seconds. And then, of course, I mentioned the multi-tenant infrastructure where, the multi-tenancy could be at different levels, departmental level, site level, whatever. And, even if you're in a hosting environment, it could be even, other customers of yours, however you set up that multi-tenant infrastructure. But again, it's primarily designed if you're using it on your, your network for you to have however you want to set up the tenancy on your network for, tracking what the different, tenants or departments or sites could be doing. And then your application continuity, disaster recovery, and metro pooling and hybrid cloud networking. So again, I mentioned earlier you could have your own, private cloud. You could have the public cloud. You could have your hybrid cloud where you have, your private cloud. You could have stuff out in the public cloud. It could all be shared. Metro pooling is just allowing, resources to be running at multiple sites, and you could actually have an application running at multiple sites by pooling the resources across, like a metro area, a multi-site area. So that's just, a quick overview of the, the 9 main use cases for NSX. So now let's take a quick look at the NSX, components, and, we'll finish up with that. So, of course, it starts at the consumption level. That's your, your cloud management system or your cloud management platform that I mentioned earlier. And then you have your management plane. We're going to look at 3 different planes, okay? The management plane, control plane, and the data plane. And it starts with the management plane where that's where your NSX manager resides. And, it's where vCenter is, and there's a message bus agent. And, again, this is where your user interface is, single point of configuration. And when, NSX Manager is deployed, there's a plugin that actually gets added to vCenter. And, you just go through vCenter to access your NSX managers. And you can have multiple managers. But the thing about the NSX managers is it is a one-to-one mapping between vCenter and NSX Manager. So to have multiple NSX managers, you would have to have, multiple vCenters. But, again, you would access the NSX Manager, through vCenter to get to that NSX Manager, interface. But again, it's all, what's already familiar to you. So. And then you have your control plane. So this is where your actual logical router control VM resides, and this is where your actual controllers. And you notice in the graphic here, there's actually 3 pictured. And the reason for that is when you deploy the controllers, it's actually going to deploy 3 individual controllers and cluster them together for redundancy, so if one controller fails, you're still going to have connectivity. And, of course, the user world agent, works in conjunction with that. And this is where all your just, uses the control plane protocol. This doesn't sit in your data path, and none of your data information actually flows through here. This is just all for, control purposes. And then, speaking of data plane, you have your data plane. That's where your hosts are. That's where your on the physical infrastructure, underlying everything. That's where your NSX vSwitch is. Now, the NSX vSwitch, what that actually is that's a combination of your virtual distributed switch. Now, for those of you that are familiar with vSphere, okay, and have worked with it before, when you buy certain editions of vSphere, okay, the virtual distributed switch is only available with the Enterprise Plus, which is the high-end, okay, vSphere. So you might be running the vSphere standard, okay? But you know what? It's okay, because even though you don't have the virtual distributed switch now, you don't have to upgrade to Enterprise Plus to use NSX, because when you deploy NSX, NSX also deploys its own virtual distributed switch. So you have the option to use the one that's already there if you're already running Enterprise Plus, or if you're not, you can use the virtual distributed switch that comes with NSX. And what NSX does is it takes the virtual distributed switch and it combines it with the VXLAN, and it combines it with the VXLAN, just like you have a physical LANs that you set up, VLANs you set up. The VXLAN, that's your virtual VLAN, if you will. Okay, and those VTEPs I mentioned earlier, what they actually are is they're VXLAN tunnel endpoints. So your VXLAN, that's your tunnel, okay, and then your VTEPs, which are the endpoints, that's where the traffic originates and where the traffic ends going into that tunnel or that virtual VLAN, if you will. Okay, so and that's all part of that virtual distributed switch. And then again, you have your distributed logical router, your firewall, everything is right there in that data plane, as part of that. And then that also is where the NSX Edge Services Gateway resides. And if you remember, I mentioned earlier, that's what you use to connect to the external, network, the physical network, or the outside world, if you will. So that's just a quick overview of the components, and that pretty much finishes up what I have. So does anybody have any questions? And I know we did a high-level overview. Did you want me to go back over anything or go a little deeper into any one of the areas I talked about? Or do you have any specific questions?
Hey, Alan, this is Liam. We did get one question during the presentation, and that was how does the VMware Evo Rail product fit into the software-defined data center?
Okay, the Evo Rail?
Yes.
Okay, yeah, because you were kind of breaking up there. Okay, the Evo Rail, all right, that is discontinued. Okay, that's no longer available. The Evo Rail has been replaced with the Ready nodes, and the Ready nodes are, it's pre-configured servers, rack-mounted servers, and what it is, it's servers that are pre-configured with pre-configured hardware for vSphere, vSAN, NSX. So when you're deploying the Ready nodes, what you're actually doing is you're actually getting hardware that's already been certified by the hardware vendor and by VMware. So the Evo Rail, that was the the precursor to that, and basically what that is now that's just the Ready node. So that's what's available from the third-party hardware vendors.
Cool. Also,
thank you.
We also got a question on if you could go into greater detail regarding the load balancing and how that works.
Okay, let me go over here and see something that I have here. Okay, just bear with me 1 minute.
Alan, did you get me?
Yes, I did. Yeah.
Oh, okay.
Yeah. So, just bear with me 1 minute. I'm checking to see if I have any more information on the load balancing itself.
Okay. Well, if need be, we can follow up on that one.
Yeah, we might want to do that because I don't have any, I've got a little additional information on the firewalling, the routing, and the switching, but not really a whole lot of stuff about the load balancing itself.
Okay, so we'll let you do some research, and I'll note who asked the question, and we'll get back to them. One final question is if you could go into detail about restricting traffic from traffic from devices in the physical network to those on the virtual network.
Okay. What that's all going to be done is that's all going to be done through that services gateway, because remember, everything that's on the actual virtual network itself, okay, all your east-west traffic, all right, that all stays right there on that network. And then your physical network has all the traffic that's on it. So what's going to happen is when you set up the services gateway is what is actually going to, communicate, with the physical network. And that's where everything else is going to take place through the physical network for you. And there's another part of that that's called the service composer, and you can use the service composer to create security groups and define security policies, and you can use those for setting up different types of membership for the group, and what you want to include, what you don't want to include, and you can do there's different types of you can do static inclusion, dynamic inclusion, things like that. And then you would set up all your different rules, and then once you have all that set up, it's just a matter of setting up whatever you want to communicate through that service gateway out to the physical network. So.
Cool. So just to wrap things up, a couple of housekeeping things. Everybody, we will be sending out a SurveyMonkey survey, so that way you can give us some feedback on this. And then if you have any further questions, please don't hesitate to ask questions with the survey, and we will make sure that you get answers. There will be some prizes available for those of you guys who fill out the SurveyMonkey. And hopefully you guys can hear me okay. I've been told my audio is breaking up a little bit. The other thing is we wanted to let you know we did a drawing during the presentation, and the winner of the Bose headsets for the attendees today is Frank Mosquera. So Frank will be reaching out to you to be able to get you your headsets. But then also, again, as I just mentioned, that you'll be getting that SurveyMonkey survey, and please fill that out, and you get an opportunity to win something else. So, or maybe even another pair of headsets. And again, any questions that we have, just because we're running out of time that you have, please put those in the SurveyMonkey, and we will make sure that you get answers. So with that, I think we're going to wrap it up. If you didn't get your pizza, because I know a couple people didn't end up getting their pizza, just shoot an email to Darren, and we'll make sure we get you taken care of. And again, from Summit Partners, everybody at Summit Partners, thanks for attending today. We hope it was as valuable for you as it was for us. Thanks.
Okay, thanks everybody. Appreciate you being here. Okay. All right. Bye now.